Hey, hi friends, very good morning to everyone. So we are seeing the components of Oracle architecture from last two classes. So last class we have seen more about SMON, what is its roles and responsibilities, and other background process and files. So today first we are going to talk about parameter file. So shortly, this is also called as B file, and you know as I told you earlier, basically whatever the parameters that are required for the database, we are going to list them in a particular file. And when you are starting up your Oracle database, it is going to read that parameter file, and according to what values you have set in the parameter file, so that way the database will be started. So this parameter file is purely a text file, and it will be having some naming convention like init sid.ra, so where sid stands for your instance name. So let me show you that over here. So suppose this is a Unix box, so where your parameter file is going to reside in Unix box, it will be under oracle underscore home slash dbs location. So oracle underscore home is the location where you have installed Oracle software. For example, on this server, if I want to know what is my Oracle home, then we need to type a command like this. So there is some setting, like how we will get this value is from environment variables. So how we will be setting those environment variables and all, we will be seeing it when we are seeing the installation part. So for example, if you have a look here, that is a complete location where I have installed my Oracle software. So if I go to that particular location, I will be having so many directories, but there will be one directory with the name DBS. So we need to go to that particular directory, and under this you will be identifying your parameter file. So as I said, parameter file will be having some naming convention like init, then your sid.ra. So where, as I said, sid is nothing but the instance name, and the Oracle gives you the option that you can have a different name for your instance and different name for your database, or you can have same name, whatever the way it is possible. So here especially it is the instance name, not the database name. So this will be your parameter file. So if you open this with vEditor, because this is a text file as I said, you will be able to see the parameters, different parameters, what are there for this particular database. So many parameters as you can see. So this is only just, the required parameters that are highlighted, but Oracle really having hundreds of parameters. So all will not be listed in this parameter file. So whatever the things that are majorly required, what are the parameters that are mandatorily required, so those parameters would be listed over here. So when you look at these parameters, so each and every parameter here, db block size is one parameter, db name is one parameter, etc., etc. So basically Oracle has segregated these parameters into two categories. One is static parameters and the other one is dynamic parameter. So static parameter means you cannot change the value of this parameter if the database is up and running. Let's say already your database is up and running. You want to change the value of that parameter. Let's say you want to increase its size. It is not possible. So whereas dynamic parameters means even when the database is up and running, you can change the value of this particular parameter. So unfortunately, we don't have any separate or segregated list stating that all these parameters are static parameters and all these parameters are dynamic parameters. So the only way to recognize whether it is a static parameter or dynamic parameter is just by getting some experience. So if you try to change that parameter and if it is failing, then you can understand it is a static parameter, and you can keep remember that in your mind. And if you change some parameter value, it changed immediately, then you can remember it is a dynamic parameter. So that is how we have the things in place. So as I said, the instance name can be different from the database name, or it can be same. So why generally we keep a different name? Obviously for the database security. So if you don't want users to know your actual database name, you can put your instance name differently so that users will be in a mood that they are connecting to some ABC database, but actually the name of the database will be XYZ. So that's an additional layer of security that we provide. Now, as you can see, parameter file is a text file. Always when you try to change some values in the parameter file, and especially in Unix platforms, we use vEditor, which is not as simple as a notepad like in Windows. So unnecessarily, if you put some extra character or extra space, so that will lead to some problem while reading that parameter file. And also, whoever is accessing to the server, they will be having a chance to open this parameter file and they can change some content of it. So overcoming all these things, Oracle has introduced something called server parameter file in 8A version. So shortly we call it as SP file, and this is a binary copy of the parameter file what you are using, which means you cannot open with vEditor. If you try to change some values with vEditor for this SP file, the SP file will get corrupted. So only with the help of the commands you can change the values of that. And similar to your parameter file or P file, so even you will be having SP file in the same location. And the naming convention will be similar. It will be SP file, then SID, that is your instance name, dot aura. So it will be in the same location as your parameter file. And at any moment of time, Oracle will give you the chance that you can create a parameter file from SP file or SP file from P file, even when your database is not up and running. So your database is down, still you will be able to create these files from each other. And when you have both SP file and P file, suppose in this case it is like that, I have both SP file as well as P file. So which one Oracle will prefer in order to, when you are starting up the database, so which file it is going to prefer? So always Oracle first prefers SP file. If it is not there, then it will look for P file. Even if P file is not there, it will give you an error. Suppose, let me try to rename these files. So already my database is up and running. So I will shut it down first. So now I'll try to start up, but because I have renamed the files, it means that no P file or SP file is there. So Oracle is going to throw this particular error, stating that it is unable to open the parameter file in so and so location. So first it will check for SP file. If not, it will check for P file. If P file is also not there, then it is going to throw you this error stating that even we don't have a P file in this particular location. So I'm just renaming only SP file, and if I say startup, it is starting. So if you want to check whether your database is using SP file or P file, then you can run this particular command at the SQL prompt. So let me show you that as well. So if you type show parameter SP file, it will show you the value or the file location and file name where it is there. So if you see some value like this, it means that your database is using SP file. Suppose here you have seen blank, then it means that your database is using P file.
Pawan, can you repeat again?
Yeah, so here whatever the things I have highlighted, so when you say show parameter SP file, if you can see some value like what I have highlighted, it means that your database is using SP file. But for suppose if you have seen blank over there, means no value, then it means that your database is using P file.
Okay. So you want to say we can't do show parameter P file. There's only SP file,
Yeah,
correct?
yeah, there is only SP file. There is no command like show parameter P file.
Okay.
Okay, so now I'm just hiding my SP file. I'm just so now I just renamed my SP file and I kept my P file. So now my database will use P file instead of SP file. Okay, so now if I type the same command, you can see it is showing blank. So this is what I am saying. If you see blank here, then it means that your database is using P file. If you are seeing some value like this, then it means that you are using SP file. That's the simplest way to check whether database is using SP file or P file. Then to change the values of the parameters, as I said, we have two types, static and dynamic. So to change the values of these parameters, Oracle has provided different options for us. So let me show you something here. Let me use SP file. Okay. So as I was saying, we have two parameters. One is static parameter and the other one is dynamic parameter. So when you want to change the value of some dynamic parameter, we have three options or two options. One is whether you want to change the value immediately or whether you want to change the value after you restart the database. So let's say, or let's take this. So there is a parameter to specify the size of the shade pool. The parameter name is shade underscore pool underscore size. Now here you can see a value of 0. Why you will understand shortly. So if I want to change the value of this parameter immediately, then we need to use in the command what we are using. So in that we need to specify some clause. So let me show you that. So let's say I want to give 200 MB to shade pool size. So if I want to have this value immediately to be reflected, then I will be using scope equals to memory. So the moment I set scope equals to memory, the value will be changed immediately. So always to change any parameter, the command will start with alter system set. That's the standard. So now you can see it is 200 MB. So from 0, the value has been changed to 200 MB. But when you use scope equals to memory, it is the value is changing immediately. But sorry, it is only for it is only till when the database is up and running. Suppose if you restarted the database, again the value will go back to 0. I'm just restarting the database. So now you can see after I restarted the database, whatever the value that was earlier there, it got vanished. This is because scope equals to memory says only for temporary time or only till when the database restarts you want that value to be changed. Now I want to change this value permanently, then we need to use the command like this. So we need to say scope equals to SP file. So if you say scope equals to SP file, the value will not change immediately now, but it will change once you restart the database. So now if you restart the database, then you will be seeing the value will be changed from 0 to 200. So now you can see before restart the value is 0, and after restart the value has been changed permanently to 200 MB. Now I want to have both, like I want to change the value immediately as well as I want to have this value permanently. Then we need to use the option scope equals to both. So this is for the dynamic parameters, because as I said that dynamic parameter value you can change even when the database is up and running. But how about the static parameter? So for static parameter, obviously you cannot use scope equals to memory. For example, we have a parameter called log buffer, which is a static parameter. So let's see what is the current value. So it is somewhere close to 7 MB or 8 MB. So because this is a static parameter, if I say scope equals to memory, it is going to give me an error stating that specified parameter cannot be modified. So for static parameters, the only option that we have is scope equals to SP file, and you need to restart the database. So until unless you restart, the values will not be impacted. So this is what it is specified for this scopes what we have. So any doubts over here? Okay, so let's move to the next topic. Now, in Oracle 9i, whatever the memory components that we saw, we use it to specify, specific size for all these parameters, like shared pool size, DB cache size, etc., etc. So what Oracle has done in 10G is it has combined all these, or it has introduced a new parameter called SGA underscore target. And the advantage for us is if you just specify SGA target to some value, intermediately Oracle will manage all the memory component sizes automatically. So what I mean to say is, for example, in my database is 9i and I have given this shared pool size as 200 MB. But we are not sure whether 200 MB will be sufficient or will be over allocated to the database. So we never know that until unless we face some issue. So similarly for the rest of the other parameters as well. So what Oracle has done is, okay, so we are introducing now a new parameter called SGA target. Suppose if you want to give 2 GB to SGA, so just specify SGA underscore target equals to 2 GB. So internally Oracle will manage out of this 2 GB, how much it need to give to shared pool, how much it need to give to database buffer cache, etc., etc. So purely the management is now in the hands of Oracle itself. And this concept is called as automatic shared memory management. So and this is in 10G version. So one thing out of all the memory components is log buffer is not a dynamic parameter. So it is a static parameter. So that's the reason it doesn't fall under the category of automatic shared memory management. So still today, like even in 12C version, you can see it is a static parameter. So dynamically you cannot change the value of it. And along with SGA size, it has also defined something called SGA max size. So suppose if you set SGA target to 2 GB and SGA max size to 4 GB, then initially your database will start with 2 GB, and if the load increases, this 2 GB will increase till 4 GB, and if the load decreases, again that 4 GB utilization will come back to 2 GB. So to maintain or to manage this automatic memory allocation and deallocation, Oracle has introduced some new process, background process, so which is shortly called as MN, but the full form is Memory Manager. So this is the change what we have between 9i and 10G SGA. So any questions with respect to this? Okay, so next we have something called alert log file. So basically when the database is up and running, there could be some warning messages or there could be some error messages recording in the database. So where we can see all such information is from this alert log file. So it not only stores about Oracle related error information, but some other things like whenever you start up the database or whenever you shut down the database or you change any parameter values or you do any DDL commands against the structures, like you created a new table space or you dropped the existing table space, you have added a new data file. So any such kind of changes you do for the logical and physical structures, or when your archive log files are generating, at what time and what is the name of that archive log file. So such kind of information also can be stored in this alert log file. So till 10G, this alert log file used to have a specific location, and along with the alert log file will only give you the brief information. It doesn't give you the complete information. So Oracle used to provide three different types of trace files. Like one we call it as background trace files. Like if there is any issue with the background process, Oracle will generate this background trace file. And second one is core trace file. If there is any issue with the operating system, and because your Oracle database is running on that operating system, so there will be a related trace file generated for that. Or if there is any tracing enabled from the user side, then what user is performing, that can also be recorded, and any such things will be recorded in these user trace files. So we used to have different types of trace files, and the locations also used to be different. Like alert log and background trace files combined together, they used to reside in one location. Then code trace files, they used to be there in another location, and user trace files in different location. So from 11G, what Oracle thought is, instead of having these files in different locations, it has combined together, and now you will be seeing all these files located in the same location, which means your alert log, background trace files, code trace files, and user trace files. All these four will be there in the same location.
Pawan, one question. If there's a deadlock, right? So that deadlock information will be in which file?
It will be there in alert log file.
Alert log. Okay.
Yeah. So alert log will tell you that so and so deadlock has occurred, and it will ask you to refer to a particular trace file. It will
Okay.
give you the location and the name of the trace file in the alert log itself.
Okay. So when that happens, we have to first look at the alert log, which will again provide more information, right?
Yes, always the first point of contact will be alert log file.
Okay.
So there is a specific location where alert log file can be there. So that is Oracle base DAG RDBMS SID DB name trace. Oracle base is something like again the location, the base location where you are installing Oracle software. So while installing, you can choose that Oracle base location and Oracle home location. So this is my Oracle base location, and under this you will see this directory, and under that another directory RDBMS, under that your database name, and under that your instance name, under that there will be a directory by the name trace. So in this location you will be having your alert log and all the other trace files. So this is your alert log file. So alert log file will always have naming convention alert underscore SID. That means your instance name dot log, and all these are background trace files. So mon, tmon, logwriter, all these are background trace files. So there will be two things again. You will be seeing one thing with the .trm extension and another one with the .trc extension. So what we need to look at is .trc extension because that will be in human readable format. So if you see, some file with the background process name included like this, then it is a background trace file. If you see some trace file with aura in between the file name, like what I am showing here, then it is a user trace file. So code trace file generation is very rare case. So it is only when operating system is behaving in a weird way, then only you will be seeing the code trace files generated, or otherwise you will see only user trace files and this background trace files. So when you open this alert log file, you will be seeing the details of that. So for example, just a while ago we have changed the parameter shade pool size. So you can see that is also being recorded here. And we have done multiple times startup and shutdown of the database. So that will be also recorded over here. So here you can see whenever we issue shutdown command, you can see it is saying shutting down instance immediate. Then it will give you the date and time on which the shutdown has been started. Then one by one it is it is stopping all the background process here. So all these things will happen. Similarly, when you say startup, it is going to show you whether it is using P file or SP file. If it is SP file, what is the location and file name? If it is P file, what is the location and file name? Then it will list you the parameters as well. What are the parameters and the values that it is using for this particular database. Then it will give you all this. So you can see background, it is starting pmon. Then there is another background process CLMN, PSPO, etc. etc. So this is what alert log will be having it. So if you want to see any Aura related errors, any Oracle errors, all the Oracle errors will be having the naming convention like this. or a hyphen, some number will be there, 5-digit number. So if you want to see whether Oracle errors are there in your alert log file, you need to just type slash or a hyphen and enter. It will give you wherever Oracle related error messages are there. Some could be warnings and some could be error messages. For example, this is a warning. It is saying that no, signaled or a 1109 is signaled, which means it is going for the shutdown. So now here if you look at, this is a error. So here it is saying that error details are there in this trace file. As I said, alert log file will give you only brief message. It doesn't give you the detailed information. So here it is saying that it has opened to fail some file, and it is saying that no such file or directory is existing. So basically Oracle is trying to open this file under this location, but the file is not available. So more details, if you want to have a look, you can check in this particular trace file. So this is how the things will be there in the alert log file. So if you open this trace file, for example, it will have much more details, like what is the date and time, what is the session ID, and then what is the module name, module in the sense what program this session is using, and some information with respect to the host here, your Oracle version and your Unix version and all, and other informations whatever you have here. So that is how we'll be having the things. And most of the times trace files would be required in order to submit the details to Oracle support. So Oracle support is like customer care. So whenever we run into some issues, there is a provision that we can contact Oracle support for the further solutions, like if we couldn't able to get the solution on our own. So during that time, they will generally ask you to submit the alert log file and the corresponding trace files. So they will be having their own tools to analyze and tell you what exactly could be the problem. So most of the times the trace files will be useful for that purpose to submit to Oracle support. So if you want to change the location of alert log file and these trace files from the default location, yes, we can be able to change it with the help of a parameter called diagnostic underscore dest, but nobody really go and change that even in real time. And from 11G onwards, Oracle provides you one more option that you can have XML formatted alert log file that will be there in this particular location. And we have a utility as well, ADRCI. So with the help of that, we can see the content of this alert XML formatted alert log file, because XML formatted alert log file we cannot see the actual content with the help of VA editor. So that's the reason we will be using a utility. But frankly to say, nobody is going to touch that XML alert log file, because reading through VA editor is much more easier than that tool. So still today many people are going with VA, the text based alert log file only. But we have an option, that's it. So next is about a recommendation what Oracle has given. So we need to just understand how the things will be there in real time. So before going further, you can have a look at how the hard disk will look like and what are the different components what we have. So basically, if you don't have a look at the hard disk earlier, you can see in this picture. So hard disk, when you open it, will have two primary components. One is these aluminum disks, not aluminum, like a steel disk, frankly to say. So there will be several layers of this disk where your actual data will be stored, and always this disk will get rotated when either reading the data or writing the data. And there is a pointer here you can see, which is just pointing to the this cylindrical disk. So that we call it as IO header, or in hardware terminology we call that as disk spindler. So what is the role of this IO header is, it is the one which is going to either read the data or write the data. So you can just compare this with a tape recorder. So hope everybody might have have experience of using tape recorder. So when you put an cassette in a tape recorder and you push the play button, there will be a small header coming out, and the tape will pass through that header. And the moment when the tape is passed through that header, it will read, and accordingly the song will be the song output will come out. Even if you want to record a song also, if you just press record button, along with record button this header also will come out, means your play button also will come out, and you can record whatever the content you want. So which means to read the data or to write the data, the same header is being used. Similarly, here also, with the help of this IO header, either you will be reading the data or you will be writing the data. Now, when you are using one hard disk for your database, then there will be a chance the performance of the database will be not as much as you are expecting. So what could be the reason for that? So let us try to understand that. Suppose I have only one hard disk for my database server. So this is my hard disk, assuming, and one hard disk itself I have segregated into multiple mount points like U01, then U02, then root file system, then swap area, then let's say U03. So I have segregated like this. Now, as I said, to write or read the data into this, we have this IO header in place. So let's say there is some DML operation performed. So when DML operation performed, finally we know that logerator will write the data into, from the log buffer cache, whatever the redo entries are generated, it will write the redo entries to the database, to the hard disk. So logwriter will not do that activity. In fact, it is going to hand over the responsibility to IO header. Now let's say your redo log files are located in U02 mount point. So log IO header is currently writing into that. Meanwhile, let's say DB also asked the IO header to write the data from the write list to the dirty block, to the hard disk. So let's say your data files are located in U01 mount point. So the same IO header need to do that activity. Meanwhile, let's say CKBT process came into picture and it wants to update the SCN number. So that will be also again taken care by IO header. But one IO header cannot do multiple writings at the same time. So what it need to do? First it need to finish log writer task because that is the one first it has issued. So basically it will work in first out basis. Then it will go with DB writer, then it will go with CKBT. So because only one IO header is doing all the task, obviously the performance of the database will be a bit low. So what Oracle suggested to avoid this situation is to use multiple hard disks instead of one particular hard disk. So let's say one hard disk you have U02, other hard disk you have U02 3, and you can make root and all there in the separate hard disk. So when you have all these hard disk in Unix, of course, there is a provision that you can map all these hard disks as different mount points to your server. And because each and every hard disk will have a separate IO header, and suppose you placed your data files in U01 mount point, so then DB writer will ask this particular IO header to write. Similarly, if you place your redo log files in U02, then log writer will talk to the second IO header. Similarly, if you have your archives located in this U03 mount point, then archiver process will talk to third IO header like this. Sorry. So like this, Oracle asks us to segregate the things so that we will be having different IO headers, and all of them can work in parallel. There is no dependency, so that the work will be or the performance will be improved. So this recommendation is called as optimal flexible architecture. Shortly we call that as OFA. So this is what this particular diagram and this particular points are saying. So you need to store all your data files, redo log files, control files, etc. separately in different disks. So that may be possible or that may not be possible in all the situations. Why? Because if you want to purchase multiple hard disks means you need to put investment. So maybe if your client is okay to put that cost investment, then yes, you can happily have that. Or if your client is not willing to go ahead and allocate the budget for that, then obviously we need to compromise on that. And the good advantage what we have with the latest hard disks, even though they are little bit expensive, nowadays the hard disks are coming with two or three IO headers. So one hard disk will be having two or three IO headers. So one IO header will be used for reading purpose. One IO header will be used for writing purpose. So this is also a bit better idea if you cannot afford to go with multiple hard disk. At least you can purchase one hard disk which is having multiple IO headers. So any questions over there? Okay. So next we have startup phases. So how we are going to start up the database and what are all the phases involved in that. So to start the database, always we would be using a single command or we can use multiple commands. So the single command that we are using always is just startup. So it is going to start the database and it will pass through different phases. So what are all those different phases? So the first phase is no mount, as you can see here. So in this no mount phase, your instance will be started. Means Oracle will read either SP file or P file. It will understand what are all the memory components that it need to collect from operating system, that is from RAM, and how much memory it need to allocate to each and every component. So it will understand all these things from this no mount state, and your SGA will be allocated, PGA will be allocated, all these things will happen. Your background process will be activated, so that will happen during instance sorry no mount phase. And when you go with so here you can see that. So if you want to go phase by phase, that is also possible. For example, here I am giving startup no mount, which means only your instance and instance will be started, which means background process will be activated and your memory allocations will be done. So from no mount state, you can go to the next state, that is mount. So if you want to go from no mount to mount, you require control file. So if the control file is not located in the specific location or in the designated location, then it will give you an error stating that control file is not available and it cannot mount the database. So the mandatory file is control file. Now what is for no mount? What is for mount? Phase. Mount is basically for maintenance. So there are some maintenance activities going forward. We'll be looking at. For example, you want to enable archeolog mode. Earlier we talked about it. So if you want to enable archeolog mode, you can do it only in the mount state. Or there are some other recovery situations where you need to do only in the mount state. So like this, we have different options or different maintenance activities. And finally, from mount, if you want to open the database for user access, then you need to have data files and redo log files. So if there is one data file missing or if there is one redo log file missing, then you will not be able to open the database at all. And after opening the database, as you know, it is for user access. So any user can connect to the database and they can do the transactions. So phase by phase, if you want to go, these are the commands that you need to follow. First, you need to say startup no mount, then alter database mount, and finally alter database open. Similarly, when you want to shut down, it will be in the reverse way. So from open, the database will be closed, and from there it will come to no mount, and finally it will be shut down. So for shutdown, we don't have any phases, but we have types. Means we have different commands to shut down the database. So as you can see here, there are four options that are available: shutdown normal, shutdown transactional, shutdown immediate, and shutdown abort. Now what is the difference between these four? We have a small table over there on the top. By looking at that, we can be able to understand. Suppose I am using shutdown normal, which is the last option in the table. So see what happens. So after you issue shutdown normal command, whether it will permit the new user connections as per this table, no. So let's say as a DBA I have issued shutdown normal command, and after I issued the command somebody is trying to connect to the database. Whether Oracle will allow? No, it will not allow. Why? Because already the shutdown process is activated. Now the second thing, whether it will wait until the current sessions end, and as per the table, yes. Means, let's say by the time I issue shutdown normal command, already one user is doing some transaction. And let's say the transaction will complete only after 2 hours. So as per this table, it is saying that the shutdown will wait till the transaction complete. Means, as I said, if we take an example that a transaction will take 2 hours to complete, so till that 2 hours, even though you have issued shutdown command, your database will not go for shutdown. So which is obviously not a good idea. Why? Because one, if the transaction is completing in 2 hours, it is okay. But what if a transaction is running for, it will run for 4 hours or 8 hours, then if we cannot shut down the database till next 8 hours, there is no meaning. So that is one problem.
One more question here.
Yes, Sachin.
Yeah, yes. So as you said, right, it won't allow new connections, right? But the already existing connection, as you said, right, suppose one transaction is taking 2 hours, right? I'm just giving an example, okay?
Hmm.
So a transaction is one session, it takes 2 hours, right? So when it is close to 2 hours, other session which was already connected, right? It starts the transaction. So again, it will wait for that transaction to complete, right? So it will go on.
I didn't get you. Can you repeat once again?
Yeah. So there could be multiple sessions, right? Logged in.
Yeah.
Correct. So suppose one session it takes 2 hours, correct, and the other sessions were not doing anything,
Mm-hmm.
or they were doing some simple select statement, right? So at the end of 2 hours, correct, the
Mm-hmm.
second session which was active uh, initiates a transaction.
Okay.
So
Okay.
again your database will wait, right, until
Right.
the transaction finishes, correct?
Right. Exactly.
Okay. Okay.
So hope others got the point what Sachin is saying. So what he is saying is, let's say I have two sessions running, and by the time I issued the shutdown normal command, already one session is doing transaction, and it will run for the next 2 hours. And when this 2 hours is about to complete, let's say there is another user who is already connected. He that user started some transaction, and that will run for another some time, like 3 hours or 4 hours. So he is asking whether Oracle will wait till that time. Yes, obviously. So for first session 2 hours, and for second session 4 hours, so totally 6 hours your database will wait like that. So which is not at all a feasible solution for real time. So that is the reason in real time we don't go with shutdown normal. Now coming to the next option, shutdown transactional. So here also, after you issue the command shutdown transactional, no new connections will be allowed, and it will not wait until the current session closed. So current session closing in the sense the user should log out from the database voluntarily. So till that time, it will not wait. But it will wait till the current transactions ends. Again, the same problem like earlier. So if the transaction runs for the next 3 hours or 4 hours, so till the time the database will wait. So this will be a problem again. And then next option we have is shutdown immediate. So here also no new connections will be allowed. It will not wait for the sessions to log out, and even it will not wait for the current transactions to close. So which means suppose one transaction is issued, it is already running from the last 15 minutes, and let's say it will take 2 hours to complete, and after 15 minutes a DBA has issued the command shutdown immediate. Whatever the changes happened in this 15 minutes will be rolled back, and immediately the database will go for shutdown. And this is what exactly helpful for a DBA. because we usually will be shutting down the database only during maintenance activities. Now and then we don't shut down the database just like that. So, and whenever you are doing the maintenance activities, we'll be having some time frames, because client will give you the downtime permission only for 1 hour, 2 hours, depends on the activity. So if this in this 1 hour, 2 hours, if the shutdown itself is taking long time, then your activity will not get completed. So that's the reason in real time always the best option to go is shutdown immediate. And finally, if you look at the last point with respect to either shutdown normal, transactional, or immediate, it is saying that a checkpoint event will be performed, and then it will close all the open files. So we know what is meant by checkpoint event. So checkpoint event is nothing but it is making sure that the dirty blocks are being written to the data files, and also your CKPT process will update the latest SCN to control file and the data file header. So all these things will happen in all the three cases. But when you go to shutdown abort, the checkpoint event will not occur, means whatever the dirty blocks that are there in the write list, DB writer will not write them to the data files, and also CKPT process will not update the latest SCN to data file header and control file. So which means if you recollect your SMON example, so if the SCN number is not up to date, it means that it is a instance crash. So all of a sudden, if you stop the database, that is equals to instance crash. So shutdown abort is the practical way of looking at instance crash. If you issue shutdown abort, it means that you are crashing the instance, and when you start the database after that, it is going to do the SMON is going to do the instance recovery. So we can practically see that as well. So let's say I have issued shutdown abort. So now, because instance crash occurred, when I say startup, SMON will come into picture and it will do that roll forward, roll back, all those things. So we can see this in our alert log file. So if you open alert log file, okay. So here if you take a look, normally if you are shutting down the database, I mean in a clean way, like shutdown immediate, then here it will show you the option shutting down the instance, then immediate. But if you shut down the database just like that, then it is not going to show you the things. It will just say, it is shutting down the database. So let me search for a small. Okay, so here you can see, this is what it is going to do. You will see a line like this, beginning crash recovery, and then it will start the redo scan. If you remember during SMON processing, I told you SMON will scan the redo log files one by one, and then accordingly it will do the recovery. So here you can see the message starting the redo scan, completed the redo scan, and clearly it is saying 145 KB of redo entries or 13 data blocks need recovery. Then it has started the recovery with the help of online redo log file, that is this one, and finally it is saying completed crash recovery. So this is how you will be seeing the messages. So this entire thing is nothing but SMON performing instance recovery, especially roll forward. So here you can see finally 13 blocks read, 13 data blocks were written, and 145 redo kilobytes were read. So this is how you will be seeing the message in alert log file. So is that clear? Any questions? So let's talk about the last topic for today, that is shared server architecture. So earlier what I told you, that whatever the architecture that we have seen is dedicated server architecture, because for each and every user process there is a dedicated server process. But at some point of time it might happen that your PJ will be going out of memory. Let's say you have your RAM size is very small, let's say 8 GB, and out of 8 GB you have operating system will definitely take something. So let's say 2 GB operating system is utilizing, so you have left out with 6 GB, and out of 6 GB let's say your SGA require around 5 GB. Means your shared pool, database buffer cache, all these components together require 5 GB. So for PGA, you have left out with only 1 GB. Now, if the number of connections are increasing, as I told, the size of the PGA for each and every connection will come down. And at one point of time, Oracle may end up with error saying that there is no more PGA to allocate to the users, the coming users. So if you have any such situation, obviously the permanent solution is to increase the RAM size, but temporarily you can fix that problem with the help of this shared server architecture. So what happens in shared server architecture is multiple users will be connected like you are seeing in the diagram, and we are going to enable a component called dispatcher. So all the requests what users are placing, like one user may run select statement, the other user may run DML statement, and the third user may issue DDL statement. So all these requests or all these statements will come down to dispatcher, and dispatcher is going to hand over those things to shared server processes. So there will be multiple shared server process. Like in the diagram, it is not there, but it is like there will be. We can specify the value, whether we want to have 10 shared server process or 20 shared server process. So we can specify that value. So each shared server process is having the capacity to handle 16 user requests. Earlier in dedicated architecture, one server process will work for only one user process. But here one server process will work for 16 users. So like this, for example, if I specify 10 shared server process, 10 into 16, totally 160 users can be served at the same time. So from here, shared server process will send the statement to uh, instance, like that is to shared pool library cache. So that processing will remain same. The processing and all will remain same. There is no change in that. Only thing is, instead of PGA, now we have UGA here, user global area. So we know that the statements will be executed in PGA. Parsing will take place in library cache and execution will take place in PGA. But here, because we don't have PGA, execution will take place in UGA. That's the only difference. Rest everything will remain same. And also, while when the request was coming from server process, it will be first placed in request queue. In large pool, we have two components. One is request queue and the second one is response queue. So what this shared server process will do, whatever the statement it is receiving, it will place that request, it will place that statement in the request queue. So in queue order, the statements will get executed. So which means first in, first out. So in that format, the request or request in the sense, the SQL statements will get executed over here. So do remember, this shared server architecture is only a temporary solution that you can use.
Pawan, I did not. What do you mean by temporary solution?
Because it means to say that the permanent solution, like how long you can run this thing. So we cannot run this thing, for permanently. So the permanent solution would always be a increasing your RAM size. Because even if you take a look at the security point of view, having individual PGA is always better than having a common area, user global area. So because there is a chance, if there is one user who is very good at hacking, that user can go ahead and see the information of what other statements are doing. So that much, impact can be there. So that's the reason shared server architecture is generally recommended for some situations. So let me show you that. So these are the things what we get out of shared server architecture. It will reduce the number of processes on the operating system because we don't have for each and every user we don't have a dedicated server process. So obviously the number of processes will reduce and you don't require much PGA. Instead of PGA now we have UGA and especially this is good when the connections and disconnections are high. So let's say your application is such a thing that users will connect, they will spend only little time, maybe hardly 5 minutes, and then they will disconnect from the database. Then that too huge number of connections at a time, like 1,000 users connecting, they will stay for 5 minutes and they will come back. The next minute another 1,000 users will connect, they will stay and come back. So in such kind of applications, this shared server architecture may be useful, but we don't know, right? We cannot say that one all the users will stay only for 5 minutes. So some users may be there for 5 minutes, some users may be there for 50 minutes, we don't know. So that is, the reason, that is a problem mainly. And also, shared server architecture is having some other disadvantages. So because you don't have a dedicated server process and you need to, like suppose you are a user, Nowadays banks are offering something called privilege banking. uh, it has different names in private sector. So privilege banking is something like you go to the bank, you go direct, you will be allocated with a specific executive there. You directly go to their desk and they will do the work for you. So you don't need to stand in a queue. Suppose you want to deposit the money, you just need to go and hand over your money and you need to tell the account number. So that person who is allocated to you, they will fill up the form, deposit form, and they will, do the work. They will do the deposit and they will give it to you. So you don't need to stand in a queue, basically. So this is the difference between the shared server architecture and the dedicated architecture. So dedicatedly there is a person, so that process is faster, or if you are standing in a queue, that process is slower. So that is what here the point is saying. Shared server architecture is having the disadvantage of slow response time and incomplete feature support. So all the features may not be supported, and even applications need to be incompatible with the shared server architecture. So there are a lot many things are involved. So that is the reason, at least in my experience, I have never seen any database enabled with shared server architecture. So if at all really we are getting in memory issues, I have seen people or clients are going ahead and they are increasing the RAM size, but I have never seen any DBA enabling the shared server architecture. But we have that concept in place. That's the only thing that we can remember.
Okay. One more question. I see the eighth point. You say user should use server equal to shared in the tnsnames.ora. Is there any other way apart from this to find out whether it's a shared or dedicated?
Not really, because the connection will come out from the client side itself. So we may not actually go ahead, and we may have a way, but as I said, never we have enabled in it in real time. So I have never checked that really, but there
Okay.
might be a way, definitely.
Okay.
And also the last point says in the same database you can have both dedicated and shared server connections at the same time. So which means you can make some users to connect through shared server architecture. You can make some connections to come through dedicated architecture. So if you want to have a particular user connected with the shared server architecture, then you need to put this clause in their tnsnames.rar file. So we will understand what is tnsnames.rar file and all. So that time I will tell you, where we need to include this clause. But almost I can say, 99.99% you won't see this shared server architecture in real time. So that is all we have for today. So tomorrow we'll be looking at what the enhancement we have in 11G architecture, and then followed by 12Z architecture, and then we will be starting off with practicals. So tomorrow I will show you uh, Linux installation. Linux installation, like I remember you people are saying uh, while Unix classes that swap thing was not mentioned. So I will show you those things, and then we will see Oracle 12C installation, how we are going to do the installation.
Pawan and out Pawan.
Yeah, Hari.
And last class I have attended that, but I have one doubt that what is the difference between the undo and flashback?
Okay, so yeah, so if we, we'll get clarified going forward. We have undo tables, undo management, concept is there. and we have flashback as well. So during that time, you will get clarified.
Okay.
So any more questions from anyone?
When we use this scope equals to both on the real time.
Whenever you want to change some value and you want that value to be no, taking immediate effect, and also you want to change that value permanently. So in such cases, you would be using that one. Okay, so let's meet tomorrow then, and have a nice day.
Thanks.
Thanks.